Alright guys, sorry I ran out of time on the last video. So we're on problem 3. We're going to follow the same directions of expressing this problem as addition, number line, and multiplication setup. So starting off with our addition, I know that if I have an addition problem with fractions, that I can never, ever add or subtract the denominators. And if the denominators are the same in the problem, which in this case they are, it's 2, 2, and 2, since they're all the same, I'm just going to rewrite that denominator as 2. Okay, nothing's changing. I'm just rewriting it down. Now, if this was 2, 7, and 9, then we'd have a different story. We have to do some other stuff, but we're not quite there yet. Just remember, if all the denominators are the same, you just rewrite it down. Now, up top, I can add the numerators, only if the denominators are the same, and in this case, they are. So 2 plus 2 is 4. 4 plus 2 is 6. So I'm going to have 6 over 2 is my is my answer, the sum of 2 over 2 plus 2 over 2 plus 2 over 2. I have 6 over 2. Now, this is called an improper fraction. It's improper because my top number, my numerator, is larger than my denominator. So I have to try to convert this into a proper fraction. I do that by asking myself, how many times can the number 2 go in to the number 6? Well, if I count by 2's, I go 2, 4, 6. I know that 2 can go into 6 3 times equally. There's none left over. I'm not sure any. 2 can go into 6 3 times. So 2 over 2 plus 2 over 2 plus 2 over 2 is equivalent to 3. Okay? Now I'm going to draw my number line here. So I'm going to go ahead and I want you to draw this with me too. I have my number line. I'm going to start at 0 like I always do. And then I'm going to have 2. Oh, I don't like those. It's too close together. I'm going to have 2 over 2. And then I'm going to add 4 over 2. And I'm going to have 6 over 2. And I'm going to have 8 over 2. Okay. So if I start at 0, I'm going to go to my first 2 over 2. Here's my first one. Then I'm going to go to my second 2 over 2, which is 4 over 2 technically, because 2 plus 2 is 4. Then I'm going to go to my third one, which is technically 6 over 2, because 2 plus 2 plus 2 is 6. Now I know that 6 over 2 is equivalent to 3, because 2 can go into 6 3 times. Now, if I want to write this down as a multiplication problem, I can just say, well, I have 3 2 over 2's, so I'm going to do 3 times 2 over 2. Put that in parentheses. Now, there's a couple of things here with this particular problem that I want to take note of. Whenever I have a numerator and denominator that's the same, it's called the unit fraction, which means anytime I have the top and bottom numbers the same, it's always going to be equal to 1. So if I had, for example, I'm going to go over here. Let's say I had 17 over 17. Well, 17 over 17 is a unit fraction, and that equals 1. Let's say I had 326 over 326. Well, that's 326 pieces out of 326 spaces, which is 1 whole. Whatever number I pick, as long as the numerator and denominator are the same, it's called a unit fraction, and it is equal to 1 whole. So if I look at this and I have 1 plus 1 plus 1, I know that 1 plus 1 plus 1 is going to give me 3. So I could have done all that without even without even solving the fraction portion of this. Just by saying, well, I know that this is a unit fraction, so is this and this, and all unit fractions are equal to 1, and I have 3 of them, so that means I'm going to have an answer of 3 wholes. Now, to solve the multiplication aspect of it, whenever I'm multiplying a whole number by a fraction, I always put that whole number over top of the number 1, because 3 over 1 is 3. 12 over 1 is 12. 15 over 1 is 15. Any number over 1 is itself. So if I took this 3 and put it over 1, excuse me, then I can multiply straight across. Now you can multiply denominators and numerators. So 3 times 2 would have gotten me 6. 1 times 2 would have gotten me 2. 2 can go into 6 3 times, which is the same answer that I just got above up here. Okay, so that was my addition, number line, and multiplication sentence setup. Down here it says, what kind of answer do you get with the above problem? We get a whole number. What is this number called? It's called a whole number. We've also talked about unit fractions. There's a lot of vocabulary that we've gone over in this lesson. But I want you guys just to basically remember that today, we just solved addition of fraction in 3 fractions in 3 different styles. We did the number line, addition sentence, and multiplication. Now you do have a worksheet that goes with this. I'd like you to complete that, turn it in for me, and your Zern goal is to complete lesson 3 by the end of the week. All right, that's it. If you have any questions, let me know.